this video we're going to work through some free fall problems. We're going to start with a stone that is dropped. It has an initial velocity of 0, and at some time later we want to figure out how far it has fallen. We don't know the final velocity. We know that it has fallen for 5.3 seconds. We're going to make down positive, and the direction is arbitrary, but we try to make it so that it's easier to work with. We try to keep the numbers positive, so I'm going to make down positive. The final velocity is down. One of the first things we're going to do is to create our variables chart. So delta x, which is displacement, vi initial velocity, vf final velocity, a is acceleration, t is the time. We know that the initial velocity is 0, and our acceleration is always going to be, for free fall, is always going to be downward. It is 9.81 meters per second squared. We also know the time is 5.3 seconds. And the first thing we want to find is what is the delta x? So how far does it fall? So we're going to look at our kinematic equations chart, which looks like this, okay? And we're going to look to see what variable we don't know and we don't need. So you're using the one that you're not using, so I'm going to go back here. And the one we don't know and we don't need is the final velocity. So I'm going to go here and I'm going to find my final velocity. I'm going to go down my chart and I'm going to see this equation right here, the second equation. And I'm going to use that equation because it has all the variables that were given or what I'm looking for. So that is delta x equals VIT plus 1 over 2 AT squared. So now I'm just going to do a substitution. VI is 0, so that's going to be 0. 1 over 2, 9.81 times the time is 5.3 squared, and I get 138 meters. So that is my displacement. That's how far this object fell over the course of the 5.3 seconds. Now I want to find the velocity, and to find the velocity, since now I know, as long as you know 3 of these variables, you can figure out the 4th one. But if you have 4 of them, then you can use any equation that has VF. So in this case, I'm going to use VF equals VI plus AT. Okay. And I know VI is 0, A is 9.81, and T is 5.3, and I get 52 meters per second. Okay. Let's take a look at another problem. This one, imagine we have a tennis ball and that we're throwing it straight up. It has an initial velocity, okay? Perhaps you hit it with the racket with an initial velocity of 60 meters per second. I'm going to make up positive. Once again, it's arbitrary. As long as you're consistent, it's fine. And I want to figure out what is the peak height. So if I hit it with a initial velocity of 60 meters per second, what is the peak height? So I'm going to start with my variables chart. So delta, instead of delta x, I'm going to use delta y because this is vertical, so delta y. And VI, VF, A, and T. So it's just like any kinematics problem, except now we're dealing with this problem vertically. And the initial velocity is 60 meters per second. At the peak, if I want to figure out the peak height, so I'm trying to figure out the peak height. The peak height is going to be 0 at the highest point. Since up is positive and acceleration is always down towards the Earth, the acceleration will be negative, so negative 9.81. And the time, we don't know the time, and we're not calculating the time. What we're looking for is the delta y. So we're going to look for the variable that we don't know and that we're not looking for, so which is t in this case, that's not going to be involved. We're going to go to our chart, look for t. This is the equation that doesn't have t, so we're going to use this equation right here. And that equation is VF squared equals VI squared plus 2a delta y. The final velocity is 0, that's at the peak. Initial is 60, and squared plus 2 times, and you got to be careful here, this is a negative 9.81 times delta y. And we're looking for the delta y. So if I take 60 squared, move it to the left, divide both sides by 2, divide both sides by negative 9.81, the negatives will cancel, and delta y ends up being 183 meters. Okay. Now, if I want to figure out how long did it take, now if I want to calculate the time, how long does it take to get to that highest point, I can use any equation because now I have 4 variables. If I have 4 variables, I can use any equation that has t to solve it. And in this case, I'm going to use VF equals VI plus AT. Final is 0. At the peak height, the velocity is 0. Initial velocity is 60. Acceleration is negative 9.81. Negative because we made up positive. Acceleration due to gravity is down. Times t, and t, we get 6.12 seconds. Okay, so this is going to be the time to reach the height. Now, this is not the hang time, so if you want to, not the hang time, but if you want to know how long the tennis ball was in the air, it would be double this, okay? Let me go ahead and just draw a graph for this first. So let's say that you want to figure out, you want to represent the motion of this ball as it goes up and then comes back down. The graph will look like this. It's going to go from positive velocity at the peak, 0 velocity, and then now it has a negative velocity. So this is the peak height. This will occur at 6.12 seconds. That's the positive velocity. This is the negative velocity, and the initial here would be 60. This would be 60 meters per second. This would be a negative 60 meters per second. The peak height would be at this point right there. So to find the time, the time it's in the air, it would just be 2 times 6.12, and that would be 12.24 seconds. This would be the total time in the air. All right, so let's take a look at one more problem. This time we're going to be thinking about a basketball player jumping. And we want to calculate the hang time of this basketball player. So here's a basketball player right here, and this player is going to jump up, straight up, okay? And the height that this basketball player jumps is given, which is 1.27 meters. We're going to make up positive. And so now we're going to set up our chart, which is delta y, vi, vf, a, and t. Okay, so this player jumps up with up to a height of 1.27 meters. At the peak height, the player has 0 velocity. The acceleration is 9.8 negative because I'm making up positive. And we're trying to figure out what the hang time is. So we don't know what the hang time is. Okay. Now, if we look at our chart, you'll notice that every equation has VI. Okay. So normally we would look at, well, what are we not using and what do we not need, and then go here and find the shaded part. Now there is a 5th kinematic equation, but we're going to stick to these 4 for right now. And so that means we're going to have to calculate. VI first before we can get the time. All right. So I'm going to use this equation, V final squared equals vi squared plus 2a delta y. Nice thing about this equation, it doesn't have time, so I don't know the time, so I can use this equation. Final velocity is 0, initial velocity is what I'm looking for. The acceleration is negative 9.8, and the delta y is 1.27. So this player jumps off 1.27 meters off the ground. The initial velocity, when we calculate this, we get 4.99 meters per second. I'm going to bracket this because I'm going to be coming back to this number in just a moment. Now I'm going to use my equation to solve the time. So I can use this one, Vf equals Vi plus AT. The final velocity is 0, that's the peak height. Initial is 4.99, we just solved that. Plus a negative 9.8 times t. Move the 4.99 to the left, the negatives cancel out, divide 9.8 on both sides, and we get that the t is going to be 0.51 seconds. So 0.51 seconds will be how long the player reaches the height, and then if you were to take that time, 0.51 seconds times 2, we get 1.02 seconds. So that would be the player's hang time. So how long it took the player to jump off the ground and then fall back to the ground.